Most people think sugar is just about weight gain. Calories in, calories out. Eat too much, gain fat. Eat less, lose it. Simple. But what if that's not even the most important part of the story? What if sugar's real influence isn't happening in your body, but in your brain? Because long before sugar shows up on your waistline, it rewires something far more powerful: your motivation, your decision-making, your cravings, your focus. It changes how you think, how you feel, and even how you behave in ways that are subtle enough to go unnoticed, yet strong enough to shape your daily life. And here's the part most people never realize. Sugar doesn't just give you energy, it teaches your brain to want more of it, sometimes at the expense of everything else. This isn't about fear or extremes. It's about understanding what's actually happening beneath the surface. Number 1, sugar is not just fuel, it's a signal. When most people think about sugar, they think in terms of energy. Glucose enters the bloodstream, cells use it for fuel, and the body keeps moving. But this view is incomplete. Sugar is not just a passive source of calories. It is an active biochemical signal that communicates directly with your brain. The moment sugar hits your system, it sets off a cascade of signaling events. Glucose levels rise in the blood, triggering insulin release. But at the same time, sensory pathways in the brain light up. Taste receptors on the tongue send immediate signals to reward centers before the sugar even enters the bloodstream. This means your brain is already responding before digestion fully begins. Deep inside the brain, regions associated with reward and learning interpret sugar as something important. From an evolutionary perspective, this makes sense. Sweetness historically indicated safe, energy-dense food like fruit. The brain evolved to prioritize and remember these experiences. But in today's environment, where sugar is concentrated in everywhere, this signaling system becomes overstimulated. Instead of occasionally rewarding you for finding ripe fruit, your brain is constantly receiving high-intensity signals that say, "This matters, do this again." In daily life, this translates into something subtle but powerful. You don't just eat sugar because you're hungry, you feel drawn to it. It starts to influence your choices in ways that don't feel like choices at all. And that's where the real story begins. Number 2, the dopamine effect. Why sugar feels so rewarding. To understand sugar's impact on the brain, you have to understand dopamine, not as a pleasure chemical, but as a motivation and learning signal. When you consume sugar, dopamine is released in areas of the brain responsible for reinforcement and habit formation. This release doesn't just make you feel good, it teaches your brain to remember the behavior that led to it. It creates a loop: action, reward, memory. But here's the key detail most people miss. Dopamine is not about enjoyment as much as it is about anticipation. Over time, your brain begins releasing dopamine not just when you eat sugar, but when you expect it, when you see it, when you think about it. This is why cravings can feel so strong. They're not just about taste, they're about prediction. Your brain has learned that sugar equals reward, and it pushes you toward repeating that experience. The mechanism behind this involves neural pathways strengthening with repetition. The more frequently sugar triggers dopamine release, the more efficient those pathways become. Eventually, the behavior becomes automatic. In real life, this shows up as habits you didn't consciously build. Reaching for something sweet after meals, grabbing snacks when stressed, wanting dessert even when you're full. It's not just preference, it's conditioning. And once that conditioning is established, breaking it becomes much harder than simply deciding to stop. Number 3, blood sugar spikes and brain stability. While dopamine explains the reward side of sugar, there's another equally important factor: stability. When you consume sugar, especially in refined forms, it enters the bloodstream quickly, causing a rapid spike in blood glucose. In response, insulin is released to bring levels back down, but this process often overshoots, leading to a drop in blood sugar afterward. This rise and fall creates a kind of internal roller coaster, and your brain feels it. The brain relies heavily on glucose for energy, but it prefers a steady supply. When levels spike and crash, the brain experiences fluctuations in energy availability. This can affect focus, mood, and mental clarity. These fluctuations influence neurotransmitter balance and stress hormones. When blood sugar drops, the body may release cortisol and adrenaline to compensate, which can create feelings of irritability or anxiety. In everyday terms, this is the classic sugar crash. You feel energized briefly, then suddenly tired, unfocused, or even slightly agitated. Over time, repeated spikes and crashes can train your brain to crave quick energy fixes. Instead of maintaining steady function, it becomes dependent on external inputs to stabilize itself. This doesn't just affect how you feel physically, it shapes your mental state throughout the day. And when your brain starts relying on sugar to maintain stability, the cycle becomes harder to break. Number 4, sugar and memory formation. One of the lesser known effects of sugar involves how it interacts with memory. The brain's hippocampus, a region critical for learning and memory, is sensitive to metabolic changes. Research suggests that excess sugar intake can impair the function of this area over time, particularly when combined with frequent blood sugar fluctuations. But the mechanism isn't just about damage, it's about interference. High sugar intake can influence inflammation, oxidative stress, and insulin signaling within the brain. When insulin signaling is disrupted, neurons may not communicate as efficiently, which can affect how memories are formed and retrieved. In practical terms, this might show up as difficulty concentrating, reduced mental clarity, or trouble retaining information. What makes this especially important is that these effects don't necessarily feel dramatic. They're subtle. You might just feel off or slightly less sharp without connecting it to what you've been eating. Over time, these small changes can accumulate. Your brain isn't just reacting to sugar in the moment, it's adapting to it. And those adaptations can influence how effectively you learn, think, and process information. Which means sugar isn't just influencing your cravings, it may also be shaping your cognitive performance. Number 5, the emotional loop, sugar and mood. Sugar's relationship with mood is often misunderstood. Many people associate it with comfort, using it as a quick way to feel better. And in the short term, it can work. But the underlying mechanism tells a more complex story. When sugar is consumed, it can temporarily increase serotonin levels, contributing to a sense of calm or well-being. This is part of why sugary foods are often associated with emotional relief. However, this effect is short-lived. As blood sugar levels drop, so can mood-related neurotransmitters. The result is a kind of emotional dip that follows the initial lift. This creates a loop. Feeling low leads to sugar consumption, which provides temporary relief, followed by another drop. Over time, the brain can begin to associate sugar with emotional regulation. Instead of processing emotions naturally, it starts relying on external input to shift internal states. In daily life, this might look like reaching for sweets during stress, boredom, or sadness, not out of hunger, but out of habit. The deeper implication is that sugar begins to play a role in how you manage emotions. It becomes part of the system. And once something becomes part of your emotional regulation, it's no longer just food. It's a coping mechanism. Number 6, sugar and decision making. One of the most overlooked effects of sugar is how it influences decision making. The prefrontal cortex, the part of the brain responsible for self-control, planning, and rational thought, is highly sensitive to metabolic changes. When blood sugar is unstable, this region may not function optimally. This doesn't mean you lose control completely, but it can reduce your ability to make thoughtful decisions. This involves both energy availability and neurotransmitter balance. When glucose levels drop, the brain may prioritize immediate survival over long-term thinking, pushing you toward quick rewards. In real-world terms, this is why it's harder to resist cravings when you're tired or hungry. Your brain shifts into a more reactive mode. Over time, repeated cycles of sugar spikes and crashes can make this pattern more frequent. Decision-making becomes more influenced by short-term impulses rather than long-term goals. This can extend beyond food choices. It can affect productivity, focus, and even how you respond to stress. Your brain isn't just processing information, it's reacting to its internal environment. And when that environment is unstable, your decisions can reflect it. Number 7, the tolerance effect. Just like other rewarding stimuli, sugar can lead to a form of tolerance. Initially, small amounts may feel satisfying, but over time, the brain adapts. Dopamine receptors can become less sensitive, meaning the same amount of sugar produces a weaker response. As a result, you may need more sugar to achieve the same feeling. This isn't about lack of willpower, it's about adaptation. The brain adjusts to repeated stimulation by reducing its responsiveness. In daily life, this can show up as increasing portion sizes, stronger cravings, or a reduced sense of satisfaction from foods that once felt rewarding. What used to feel like a treat becomes normal, and what used to feel normal may no longer feel like enough. This shift happens gradually, often without awareness. But once it occurs, it changes your baseline, and when your baseline changes, your behavior follows. Number 8, sugar and attention. Another subtle but important effect of sugar involves attention and focus. The brain requires consistent energy to maintain concentration. When blood sugar levels fluctuate, attention can become unstable. High sugar intake can lead to rapid energy availability followed by a decline, making it harder to sustain focus over time. Dopamine plays a role here as well. When the brain becomes accustomed to frequent reward stimulation, it may struggle with tasks that provide slower, less immediate rewards. This can make activities like reading, working, or studying feel more difficult compared to quick, stimulating inputs. In real life, this might show up as difficulty concentrating, increased distractibility, or a tendency to seek constant stimulation. It's not just about energy, it's about how the brain prioritizes attention. And when sugar becomes a frequent input, it can shift that prioritization. Number 9, the habit loop. At this point, all the pieces begin to connect. Sugar influences reward, stability, mood, decision-making, and attention. Together, these effects create powerful habit loops. A cue triggers a craving. The craving leads to consumption. Consumption provides a reward. The brain remembers the pattern. Over time, this loop becomes automatic. The key detail is that the brain doesn't distinguish between good and bad habits. It simply reinforces what is repeated. This means sugar habits can become deeply ingrained, even if they don't align with your goals. Breaking these patterns isn't just about stopping a behavior, it's about changing the underlying loop. And that requires awareness, because once you see the loop, you can begin to interrupt it. Number 10, what this means for you. All of these mechanisms point to one conclusion. Sugar's impact on the brain is not just about taste or calories. It's about influence. It shapes how you feel, how you think, and how you behave in ways that are often invisible. This doesn't mean sugar is inherently harmful in all contexts. It means its effects depend on frequency, quantity, and pattern. When used occasionally, the system remains balanced. But when exposure becomes constant, the brain adapts, and those adaptations can shift your baseline. Understanding this gives you something powerful: perspective. Because once you understand the mechanisms, your choices become more informed. Sugar is often reduced to a simple narrative, good or bad, healthy or unhealthy, but the reality is far more nuanced. It's not just something you eat, it's something that interacts with your brain on multiple levels, influencing reward, stability, mood, memory, attention, and behavior. And most of these effects don't feel dramatic. They feel normal. That's what makes them powerful, because when something feels normal, you don't question it. You don't see the pattern. You just live it. But once you understand what's happening beneath the surface, the picture changes. You start to notice the subtle pull toward certain foods, the shifts in mood, the patterns in your focus and energy. This isn't about eliminating sugar completely or fearing it. It's about understanding its role in your life and how it shapes your brain over time. Because the real question isn't whether sugar is good or bad. It's whether you're aware of what it's doing. And once you are, you're no longer just consuming it.